by the ward. Here's the intensive care unit. We can pick any patient there. And at that point, when we click on the button here, it then holds a conversation with the lab computer, downloads the information, and allows them to do it. Now, the problem we immediately had with this was it was too popular. We didn't have enough Macs in the ward, so people were queuing up in the morning before rounds and saying, I want to get my graphs out for 5 o'clock, 6 o'clock rounds. So we said, how about if one is able to say, I'm going to do it at 4 o'clock in the morning, beat everyone else. Graph, I don't need the numbers, so I'll get rid of those. And then 11 hours later, before I go home, I want to have the same thing done. Every day from now on, at 4 o'clock in the morning, 11 hours later,
you can automate that process, yeah.
They can pick it up in the laser printer.
Okay.
So the idea is, of course, you're using the computer less this way, but you're using information resources better.
Right.
Another thing that we've done to try to tune this to the individual clinician is saying, what if he doesn't like these panels? And a lot of clinicians feel very strongly about the way they do business, and they want to do it that way. We allow them to create their own panel. Here we'll clear the old ones and put in a new one.
And a panel is that combination of information, test results,
That's right.
or whatever.
And they're usually be related together
Okay.
to give a particular answer that one test can't give. We'll call this a PBS. And this will go ahead and set up those 4 tests for a query. We want to do it right now. But more importantly, whenever I sign on, again, I'll see a PBS1, but only when I sign on.
Yeah.
This has been tailored to
So that's
the
our
individual
custom
clinician.
panel.
That's correct.
Okay.
Okay, so that's a gist of the major features of the laboratory package. Other types of things we try to do is again, if I want to go to the X-ray department, I should be able to address it in a similar way. The problem there when you go to the X-ray department is usually they give you a huge manila envelope, everything is in there, and it's difficult to find the films. If I just want to find the X-rays of this lady's head, I'd want to just click on the lady's head, see the types of studies that can be done, and here's the CAT scan. If I click on that, I get the information on what the radiologist has said on that. And finally, if the infrastructure is possible in that hospital, we could actually bring up the CAT scan and take a look at it.
All right, Dr. Schultz, let me kind of go back to Heidi's question in a way. Is all this computer technology just saving costs in the practice of medicine here, or is it improving healthcare at the same time?
Oh, I think it's clear that it's improving healthcare, and I think that the winners in the future are going to be the people that are able to effectively use computers to show that they can take care of patients better. I think that's what the government's looking at very closely now, too.
And Dr. Helvey, before we finish, I want to clarify with you, when we were looking at that MDX service,
yes,
that may be available on some online services like Jeannie, you were saying, so you wouldn't necessarily have to go to a library and necessarily buy that whole database.
No, that's correct.
And if you did buy it, there's an update?
Yeah, monthly we'd send the update or the abstracts.
Thank you very much.
You're welcome.
Well, for an eye doctor, the diagnosis of retinal disease requires a close-up look at the veins and arteries in the back of the eye. Now, thanks to computers, ophthalmologists can do a better job using video angiography. Here's a report.
Good. Now down here.
Eye surgery is a delicate operation that requires extreme precision. Ophthalmologists at this clinic in Los Gatos are using a new video imaging system from ImageQuest to guide them in their work. A photographer uses the imaging device to produce digitized images of an angiogram. His machine is connected to a Macintosh 2 computer and a high-resolution video camera to capture the pictures. The images from the angiogram appear almost instantly on the screen.
The physician can review these within seconds of them being captured and actually can make a diagnosis virtually on the spot. Because these images are in digital form, they can then be computer enhanced. And in some cases, we seem to even see more detail on the computer enhanced image than we do on our classical 35mm photographs.
The images are stored in a HyperCard program. HyperCard allows the doctor to manipulate the pictures of the retina and enhance the portions he needs to see. They can be sharpened, brightened, and even colored to highlight the problem spot. The doctor can also print a 16-image proof sheet.
When we're obtaining the images immediately from the screen, we minimize processing costs, we have no darkroom costs, we have much less technician time involved in obtaining the results. And this is a significant cost savings.
Now, instead of waiting days or even hours, the ophthalmologist can diagnose the problem within seconds after the procedure before treating the patient's eye with lasers. For Computer Chronicles, I'm Elisa Clancy.
In the same way that flight simulators are a practical way to train fighter pilots without risking their lives, clinical simulations enable doctors to practice their skills without having to use real patients. Here to show us one such program is Professor Hurley Myers of the Southern Illinois University Med School. Also with us, Dr. Ralph Smathers, developer of the mammography teaching file. Heidi?
Dr. Smathers, with the explosion of medical information that's now necessary to teach the medical student, particularly in radiology, do you find that this type of technology as applied to this helps you fit all that in to the normal residency period?
Yes, on one laser video disc we have over 400 actual clinical cases with all of their mammographic images, and so several thousand images, all accessible in an interactive mode. And the student can review these on his own time, be it a medical student, a technologist, or a radiology resident, on their own time, go through all the cases before they actually begin the clinical services and be that much better prepared.
All right, Dr. Myers, now at Southern Illinois, you've got this DXR system you've developed. Tell us about that.
Well, we've been working with the Macintosh computer and a HyperCard authoring tool to develop this simulation. It basically simulates the doctor-patient encounter. We call it DXR, or Diagnostic Reasoning, and we use it with our first-year medical students, although we've designed it in such a way that it can be used with a multimedia format so that you can do advanced students as well as doctors, but it is a simulator.
And what you have here, you've got a video disc player hooked up, a CD-ROM drive hooked up,
correct.
All into the Macintosh here, right?
That's right.
Show
Well,
us
you
how
see.
use it then.
Okay, well, this is the Christine Brennan problem, and we based this in large part on the principles of problem-based learning, which is used in a lot of the medical schools now to educate medical students. One begins or gets introduced to the case or the patient. Here we have a young lady that has dizziness, and now what we want to do is investigate this problem, and we do this entering into the case itself with a little bit more general appearance information. And now we've conformed to the HyperCard format, and we put buttons and icons in here, and we can ask the patient questions or do the physical exam. I'm going to go on to the physical exam component of this and show you some of the multimedia capability. We'll open up our doctor's bag, and inside our doctor's bag we have the doctor's tools, and we use those to investigate the patient. For example, if we wanted to take a look at the eye, view the eye, we would select this